Okay, maybe we should start on time. Welcome to the last session, which will feature keynote, Professor Michael Kremer. He is a Gates Professor at Harvard and AAS Fellow. He has numerous of papers at top journals, including Science. But what I really want to say about him is the topics he covered is really, really broad. Okay, from O-ring, 1 million years of population growth, self-control, disorganization, HIV, and many other issues, including elephants, the open access resource, and of course the worms, the topics, he's going to talk about, especially after Theresa May lost her majority.
Okay, well, that's news. I didn't realize that. Okay. Well, thanks very much. I think this paper will actually pick up on a few different themes that have come up earlier. Let me say first, this is based on several different papers, but and they each have their own co-authors, but let me highlight Sarah Baird, Kevin Croak, Joan Hamori Hicks, Eric Hsu, and Edward Miguel as co-authors who come up in various places here. So there's a question of when, let's see, do this right? Okay. There's a question of when and how governments should intervene in health and how much they should spend and what cases they should spend on. And one sorry, let me go back to my first slide. So in the case of developing countries, the WHO Commission on Macroeconomics and Health, which was led by Jeffrey Sachs, has been very influential in policy terms. And their argument had been that better health spurs growth. And they based that largely on cross-country analysis. And while that's been, so for example, regressions of growth rates on malaria, for example, or particular types of malaria, while that's been really influential in policy terms, at least in the period after publication, intellectually there are a number of gaps in that. So first, there are some pretty serious empirical issues of identification, and the modern growth literature, which uses ID estimates, is really no longer focused on health. And in fact, the disease and development paper, for example, is probably better identified and doesn't lead to the same sorts of growth conclusions. I would argue, equally important, there's a disconnect from welfare economics or public finance, right? It's not clear that growth maximization should be exactly the objective of governments. How much should you spend, et cetera? It's hard to use growth impact as a guide to practical decisions because there's many different health conditions and you can't do growth analysis on each of them. If we believe what we just heard about the results in Sweden on school lunches, that sounds like a great policy, but you're not going to be able to run a regression of growth on school lunches. You'd quickly run out of, have many more health policy variables than observations. And of course, health's also a final good, so we should be valuing it for that sake as well as for any instrumental value. And you'd like to integrate that in. If healthcare expenditures on the elderly, for example, who've already retired might not show up in a growth regression, but you might want that to still take place. So a couple of other approaches I think would get sort of more traction with this audience. One would be, and this is something that's popular in the academic world in the US, and I don't know if it's popular anywhere else, but is to think of the government role as to address market failures. So if you take that approach, and I think there's a lot of merit to that approach, then the optimal subsidy, I'm just thinking of subsidies right now, not regulatory policy or other things, because I'll be focusing on an infectious disease case, depends on a number of factors. And actually, I haven't written up equations here, but it depends on these three factors, and you can write equations for that. Depends on the magnitude of the market failure. So focusing on the case of externalities, how big is the externality? So if it's a communicable disease epidemiological externality, but yes, there's an externality, but it's very small, that would tend to not justify as large a subsidy. It depends on the ratio of marginal to inframarginal consumers. So if you're trying to get people to, say you're trying to get people to take a vaccine, but imagine that almost everybody would have taken the vaccine without the subsidy, then by subsidizing it, you're paying a lot of inframarginal people who aren't changing their behavior. So at some level, not at some level, sort of very precisely, things depend on this expression that shows up in public finance all the time, which is the density of the distribution of whether people are how a subsidy, the number of marginal people who will be influenced by a subsidy, divided by the number 1 minus f, that's the fraction of people who are going to take this drug anyway, or vaccine, or whatever it is, and who, therefore, you're just spending money on without a benefit. And it's also going to depend on the deadweight loss of taxation. Okay? So in much applied public finance work, people will just use a number for the deadweight loss of taxation. They used to think maybe it was 1.4. It costs $1.40 to raise $1 for the U.S., $1 of tax revenue. Then people sort of moved this down to 1.2, following some new work on the elasticity of labor supply. But actually, the modern approach to this doesn't suggest that there should be a simple number at all, because where does the deadweight loss of taxation come from? It comes, perhaps from other sources, but it comes from distorting labor supply downwards. But the nature of the intervention, you could imagine if you're thinking about, building a park, then that might cause people to take more leisure, and that would reduce tax revenue. Or you might be doing something that increases labor supply, and that would have a counteracting effect. So actually, in this framework, what you get out of this is that the labor market impact is potentially going to be very important of what it is that you're spending the money on. Okay, now so this approach, this approach of addressing market failures suggests, yields this thing that the labor market impact is going to be important. Then the other approach is just to assume that the government's the healthcare purchaser. So this is what the UK would do, what many, just a straight cost effectiveness analysis. Don't need to think about market failure, look at how much you spend on it and what you get out of it. And and there, clearly the economic impact is going to affect the calculation. So for example, one way of calculating DALYs or QALYs is you subtract off any economic gain from the cost, and you do your DALY calculation that way, or QALY calculation that way. So either way, the economic impact is going to come in. So what should we think the labor market impacts are going to be of health interventions? So there's some theory that can guide us on this, and I'll also be presenting some data. So the theory suggests the sort of oldest and most foundational version of the theory would be the Grossman health human capital model, which suggests that health investment say as a child, or would affect your future endowment of healthy time. And if that increases your time, maybe you've got more time to spend on education. So a lot of literature are focused on education, and took that as an indicator of how did education respond to early health things. Now Bleakley raised a very interesting point after some of his analysis, which suggested that some health improvements led to education gains and some didn't. And he pointed out that how you allocate this extra time that you have, extra healthy time, will depend in general on how health increases your relative productivity working and how it increases your relative productivity in education. If you're stronger, that might just increase your labor market returns, and it might cause you to work more instead. Pitt, Rosenzweig, and Hassan say, okay, it depends not just on sort of the production function of how health affects labor productivity and productivity in school, learning in school, but also on the relative prices that are attached to each of these things. And they argue that in very poor economies where brawn is important, and if men are endowed more with brawn, then they argue that health improvements will cause men to further specialize in that and will cause women to invest in human capital. Okay? And they have both a model and some empirical evidence for that. Okay? So that's some of the theory. Let me say what I'll try and do focusing on this case of deworming. So I'll give you some background on worms in case you want to learn more about worms. I'll talk, I'm actually next going to talk, I changed the order of the slides on the plane, but not the outline slide. I'm going to talk about evidence on the elasticity of demand, which is one of the ingredients in this calculation of the optimal subsidy. Talk about short-run impacts on education from an earlier paper, and evidence on externalities from an earlier paper. And then talk about a recent paper, which is on the long-run educational and economic impacts, which is also going to feed into the optimal subsidy because of the fiscal effect through this through the impact on other taxpayers comes in there. And then we'll do the sort of benefit cost approach. So all of this feeds into the market failure approach, but we'll also present, let's say you don't want to, you don't believe in that type of stuff and you just want to do a benefit cost calculation, we'll do that. We'll spend a lot of the talk on this, but then I also wanted to talk about some recent meta-analyses that came out and discuss those as well. So there'll be sort of two parts of the talk. Okay, so the background. Intestinal worms affect nearly 1.5 billion people worldwide, although I'm sure there's a lot of uncertainty around that estimate. Infections can cause anemia, malnutrition, stunting. They can reduce immune response, which actually some people in rich countries now want their immune response reduced and deliberately infect themselves with worms, although that's a very fringe thing, not endorsed by medical authorities. The symptoms of deworming are going to depend very much on the intensity. So this is something very important to bear in mind in terms of the underlying science. If you just have a single worm in your body, that's probably not going to do much. But the big effects are going to be when you've got lots of worms, and the distribution is very skewed in the population. It's also correlated with prevalence. A lot of people have light infections, a small number of people have moderate or heavy infections, but the heavier the prevalence in the society, the more you go up that scale. The treatment that's available is safe. It's very widely used. Hundreds of millions of people. It's also very widely used in animals, and it's efficacious. It's very cheap. The pills themselves cost maybe 2 cents for soil-transmitted helminths is one category that costs about 2 cents per dose. They're more expensive for schistosomiasis. Treatment is, if somebody's infected, there's complete consensus that they should be treated. That's considered the standard of care. It'd be considered unethical not to treat them. Here's pictures of a roundworm and a hookworm. Now, diagnosis is pretty tricky for worms. So while treatment is very cheap, diagnosis is expensive, and it's logistically very difficult. You have to find somebody, get a stool sample from them, which isn't so easy, take the stool sample to a lab, find out the results, then find the same person again, give them the medicine. So it's people think it's 4 to 10 times as expensive as the treatment, and it's also imprecise. The sensitivity and specificity of the test isn't great. So, as a consequence, the World Health Organization has, for a long time, recommended MDA, mass drug administration, in areas where there's high enough prevalence, and that's not based on some of the things I'll talk about here of the educational or economic impact. This predates any of the studies that I'll talk about here. It's based purely on the health impact. What they recommend is treat at least once per year, or treat once per year where prevalence is above 20%, and treat multiple times per year, which in practice typically means twice per year, where prevalence is above 50%. School-based treatment, one of the things they really advocate is school-based treatment, and that's because school-based treatment is particularly cost-effective. If you have to go, door to door to find people who've got, to give out the pills, that's going to be much, much more expensive. If your kids have very high prevalence for various reasons, and they're also they do a lot of spreading because they're, for example, more likely to defecate outside rather than in a latrine. So getting kids when they're all gathered together in one place makes this very cost effective. The cost per treatment, including the delivery costs, I think quite well calculated, this by GiveWell. They estimate 30 cents, so including the value of teachers' time, et cetera. They estimate 30 cents per treatment in India. Probably somewhat more expensive other places. So several of the studies I'll mention here are based on an evaluation of a program in Kenya called the Primary School Deworming Project. This program was phased into 75 primary schools with 30,000 children based on list randomization. Schools were sort of lined up in order by district, by alphabetically, and then count off 1, 2, 3, 1, 2, 3. The NGO that did this had a policy of cost sharing. They believed on, they had a very strong attachment to the idea that people should be paying something. You shouldn't give away things for free, which many NGOs feel. But in part, they agreed to only bring this in half the schools and test it. And as I'll discuss later, they found that this was, really cut demand a lot, so they then got rid of it. There's one thing to note is this is a setting with high baseline prevalence. 92% of people had worms of some sort. 37% had at least one moderate to heavy infection, okay? The ones that are likely to be more serious. And that was partly because it's an area near Lake Victoria and so on, partly because there were a lot of rains that year, which facilitated the spread. Okay. So first issue is elasticity of demand. What is this F over 1 minus F? So we found when the NGO introduced this cost-sharing requirement, the take-up, the number of kids who actually got the medicine, went from 75% down to 19%. Okay? And by the way, the 75%, that was, probably would have been many more would have taken it, except because this was a part of a study, the parents had to come in and sign a permission slip. Not everybody got around to it, so probably it would be more like 100% if it were in a much closer to 100% in a standard program where parents can opt out if they want, but you have to actively opt out for your kid not to be treated, or the kid has to refuse it. In any case, the F over 1 minus F here is going to be, there's a lot of marginal people relative to inframarginal people who would have paid for it. Okay. Now, this was a relatively small fee. A couple of paradoxes that I'll note. First, the fee was on a per-family basis. So this was cheaper if you had 3 kids in school than if you had 1 kid in school. But there was no greater take-up among families with more kids in school. There's also no evidence that families were more likely to pay for sicker children, for kids who had worms as opposed to those who didn't. Okay. So one term in this equation is this f over 1 minus f term. A second term is going to be a lot of this is going to go into calculating the fiscal impact or just straight into a cost-benefit calculation. So what's in our earlier work, 2004, and with some corrected things in 2014, which I'll explain, there was we didn't find a cognitive gain, which again might not be so surprising if we think about Doug Allman's talk and theories of child development. Kids who these were school-age kids already. They might be past the critical child development window. But we did see increased school participation. Some of the symptoms of this can be lethargy and so on. So kids are just feeling better. They're coming to school more. We do see self-assessed health that improved. We also saw evidence of epidemiological spillovers. That's going to be another term in this. We saw reductions in infection among untreated kids, both untreated kids in treatment schools. So during this period, now it's WHO's recommending it for everyone, but there were girls, they didn't know about whether there might be effects on development of the fetus, so they were telling girls over 13 not to take it at the time of this. But later they decided that that was safe and to go ahead with it. We also saw gains in both reduced infection and increased school participation. So these are sort of 2 outcome variables in 2 different settings within the school, which isn't perfect, which is not perfectly identified, and in nearby schools. Among so the nearby schools, originally, in our original paper, we thought this went out to 6 kilometers, but there's a programming error. It only went out to 3 kilometers, or if we break it down, probably a little bit further than that. We limited the analysis to 12 schools, and there were never more. That didn't affect the estimate within 3 kilometers, because there were never more than 12 schools. But sometimes there are more than 12 within 6 kilometers. Okay, so if you take these estimates of the increase in school participation, this looks, if you're just doing this from a benefit-cost perspective, if you forget your health hat and just imagine this were an education conference instead of a health conference, one of the things that people in education care a lot about is school participation. So you can ask, what's the cost of if you spend $100, how many extra years of education do you get for this as opposed to other interventions? And let me just emphasize that all of these interventions are probably very good things. There's a bunch of things that aren't shown where there's no evidence at all, or where there's no effect. So comparing this to things like free primary school uniforms, merit scholarships, conditional cash transfers, some unconditional cash transfers. Now, some of these things have other impacts, but so does deworming. So you can see, huge. This is extremely cost effective. These are studies in Africa, I believe. Okay, here's studies in Asia, and studies in Asia. Again, this is not. We don't have a deworming study there, but these slides are from JPAL. This is iron fortification and deworming in preschools versus a number of other interventions. The thing that comes out better, I believe, is in terms of cost effectiveness is the Jensen informing children of the rates of return to education, Dominican Republic. Okay, so those are sort of education impacts in the short run. Osier has a nice paper looking, not examining the kids who are treated, but examining younger kids in the same area from the same experiment. And he estimates the cognitive impact 10 years later, again, very consistent with Doug Allman's work and other work in that line. So what he finds is for the children under age 1, and I don't think he looked at the children under, the children that were still hadn't been born yet, but I'm not sure there would be an effect there because school-age children or young children are the ones who are most infected. Anyway, what he finds there is a gain of equivalent to a cognitive gain of 0.5, equivalent to 0.5 to 0.8 years of additional schooling. And that's particularly strong if they had an older sibling who was eligible for treatment. He didn't find effects on older children. And because these children weren't treated, this is another source of evidence in support of the idea that there are epidemiological externalities. These are sort of transmitted by feces typically. Okay. Okay. What about long-run effects? So this is a recent paper with Baird and et al. So this is based 10 years follow-up, 10 years after the original intervention. And we find results that are very much in line with this Pitt, Rosenzweig, and Hassan paper, with a gender differential in effects. So consistent with Pitt, Rosenzweig, and Hassan, we see men increasing their labor supply. And that's 17%. Men actually don't have very high labor supply in this population at this age. So that's by 3.49 hours per week. And we see log total labor earnings increase by 24 percentage points. So slightly bigger, but point estimates would suggest higher earnings per hour, but I don't want to, it's not, you can't reject that these two numbers are the same. There's also, from a very low base, there's an increase in likelihood of working in manufacturing. When I say working in manufacturing, don't think they're working in an automobile factory. They're working at a very low-end manufacturing job, typically. I mean, some are in textile factories, but there's also just operating the grain mill in the village, for example. Women, on the other hand, we didn't see an increase in labor supply, but we saw an increase in education. So they were 9.6 percentage points more likely to pass the secondary school entrance exam. They were in primary school at the time of the study. So 41% was the base rate of passing. That increased by 9.6 percentage points, so about a 20% increase. And a similar percentage increase in actually attending secondary school. We saw some shift from agricultural to non-agricultural self-employment. We mentioned some evidence from a study in the U.S. South. This isn't an RCT. It's a difference in difference study by Bleakley. The Rockefeller Foundation financed a deworming campaign in the early 20th century, and he uses a difference in difference analysis based on looking at the initial level of worms in an area. Obviously, if you didn't have worms, you couldn't benefit from this. So he estimates very similar effects. And this was done before our study, before our follow-up study, that looked at these longer run effects. And interestingly, the numbers that we get he actually predicted what we should get in our context, and it was not far off. But same sort of education increases and income increases. I should actually ask White about the gender breakdown and see if he finds anything in that context. Okay, so we've got several of the elements for this this study to get at these welfare calculations or benefit cost calculations. So if we do the public finance approach, focusing on market failures, how can we do this? Well, some of the things we can't get, but we can bound those things, and then we can get the other things. So what's a lower bound on the benefit to the beneficiaries? Well, if we want to be very pessimistic, we would say that people who were not purchasing this and who purchase this, who get the deworming medication as a result of the subsidy, maybe their gain is just epsilon because they really didn't like deworming and they barely got moved, they barely moved it, so we're going to ignore all of those. But a lower bound would be the people who are going to take the medicine anyway, they benefit by the amount of the subsidy because they would have paid this before. So that 19% of the population that would have paid and now gets it for free gets some value. It's actually less than 19. The 19% is with a partial subsidy. With no subsidy, the status quo was under 5%. Okay. What about these communicable disease externalities? Well, it's hard to put a dollar value on that, but it's clearly going to be positive. So again, we'll take a lower bound on that. So given the elasticity of take-up, we can then calculate the fiscal impact on taxpayers of zero, partial, or full subsidies. And what we find is that our best estimate of the net present value of the extra tax revenue from the full subsidy, so remember, people are working more hours, they're earning more. So if you think, so you're going to be very seriously led astray if you just say, well, let's take the cost of this program, multiply it by 1.2 and 1.4, and that's going to be our deadweight loss as a result of this. Actually, everything's going to go in reverse because people are working more out. The people who get the medicine are working more hours. If they're working more hours, that means there's more tax revenue. I mean, marginal tax rates are low in Kenya, but these are big increases in hours. So when you work it out, our best estimate of the net present value of the extra tax revenue from a full subsidy is greater than the cost of the program, which means that the taxpayer actually saves money. So to the extent there's a deadweight loss of taxation, that actually is just going to increase the benefit. And I should say, there's standard errors around this, and there's wide enough confidence intervals, we couldn't reject the possibility that this condition isn't satisfied. But this is a very strong condition. Given all the other very conservative assumptions, this is a sufficient condition, but not in any means a necessary condition for this to be desirable. But anyway, if you go with the point estimate, which I would argue you should, this suggests that a full subsidy is worthwhile. Okay, what if you do the benefit cost approach? Well, the best estimate of the net present value of future earnings, net of the increased schooling costs, is more than 100 times the cost of the program. So this looks like extremely cost-effective from a benefit cost perspective. And it also means that even if you got substantial uncertainty around that, it would still be the case. And you would want this 100 times estimate, you might want to shrink for several reasons. First, this is a high prevalence area. So if you're trying to extrapolate to a lower prevalence area, the effects are probably smaller. And then second, this is a little bit, maybe more philosophical, but if you do what, say, JPAL does, of, say, rank a bunch of things by cost effectiveness, if you choose the things that are most cost effective, then you should expect that some of that estimate of what's cost effective is due to the true effect, but some of it's probably also due to, you've got sampling error in all these different studies of uniforms and school lunches and deworming. And so if you select on the one that's most cost effective, you should expect that partly that's going to be due to sampling variation. Okay. In any case, a lot of bodies which review evidence on cost effectiveness of different interventions, classify mass drug administration as highly cost effective. And these are examples. So in this case, for either intervention, you would want full subsidies. You might actually even want more than full subsidies, but that's probably logistically very difficult to do. So now let me switch gears a little bit and talk about, so I think there'd been, despite all of this, there's been some debate recently about deworming, and that's in large part because of what I'll talk about in this remaining portion of my time, which is some meta-analyses that have been done. Just check the time. Okay. So in particular, there was this Taylor-Robinson et al. Paper, which was influential in part because it was a Cochrane review. Now, what they do is they break up the studies into studies that are taking people who are known to be infected, so they've been tested and found to be infected, and then those are randomized into treatment and comparison. And then studies of mass drug administration. So among those known to be infected, they estimate an average weight. They look at a variety of outcomes, but we'll focus on weight gain because that's by far for a number of reasons. One, they list it as one of their main outcomes. Two, it's height is not something that you can affect in a short period. Hemoglobin is thought to only be due to affected by hookworm, not the other ones. And there's not many studies in their sample that go at that have hookworm. So for the people who are known to be infected, they estimate this average weight gain of 0.75 kilograms. And so they, like the rest of the health world, strongly endorse treatment of those who are known to be infected. But then they do something that strikes me as perhaps throwing away some data, which is they separately estimate the effect of mass drug administration in a population as a whole. And there they reach this, what I would consider a pretty strong conclusion. They argue there's substantial evidence that there's no impact of mass drug administration on average nutritional status. So it's based on 11 estimates from 10 studies. Why is that? Why do I consider that a strong estimate? Normally one might say we fail to reject the null of no impact, or we fail to reject the null of no average impact, but there's heterogeneity or something like that. They don't say that that's not their headline result. Okay? Now then, some of the authors have then gone on to say, well, we can't have these long-run educational and economic impacts because there's no short-run health impact. Now, there's a lot of controversy about this in the health literature. Some making arguments of, I've had patients who, occasionally you can have very severe consequences of these heavy worm infections. So sort of the old-fashioned doctor saying, I've had patients and I know they benefit, they were hurt by this. And I don't mean to make light of that. And then a lot of other health people say, well, this isn't one category. There's different prevalence levels. There's different intensity levels. There's different worms. There's different drugs against the worms. You've got to consider this separately. Okay. Okay. So, the reason why I don't make light of the first is we know that there's cases where severely infected people, you can, see very, physical symptoms that are problems. Okay. So the policy question here is, should the WHO continue to recommend mass drug administration in areas of high prevalence? Okay. And there, I would argue, I'll come back to this later, that you probably want to set this up as a Bayesian decision problem, but the clear criteria is, do the expected benefits exceed the costs? Because this isn't a case where nobody's arguing that there are side effects from this. This isn't, should the FDA approve a new drug? It's a drug that's already approved, and when should you spend public funds on it? It's a financial issue at some level. So here are some concerns with this study. So first, they don't report statistical power. And in fact, I'll argue that their power is very limited. They don't report a test of the common zero effect. If you think about their claim, substantial evidence of no impact, you would think the natural test for this would be, can we say that the effects are zero everywhere? But there are many other issues which compound this problem. So they missed multiple studies in their analysis. This includes studies not that they sort of talked about and said, well, we want to exclude, but just ones that weren't on their radar screen. Then they omit other studies because they don't follow the Cochrane procedures for imputing standard errors from p-values. So some of the studies report p-values and report intracluster correlations or other relevant factors from which you can back out what the standard errors would be. But in the Cochrane handbook, which is quite good, gives procedures for doing that, but they don't necessarily do that. So this is going to lower statistical power. This is going to lower statistical power. Then often they don't use the baseline data, and that thereby give up more statistical power. they also include studies where the soil-transmitted helminth prevalence is less than 20%. So if you're trying to test the WHO policy and you include places with very low worm loads, then you're going to obviously bias the estimates downwards, but then you're also going to blow up the standard errors because there'll be more variance here. Then another thing is they changed their inclusion. So there have been a series of these Cochrane reviews. And in their previous review, and in their earliest review, in the earliest review, they didn't separate out the test and treat from the Mass Drug Administration, which I think probably should be on this list as well. But then they started doing that. But in their latest review, they decided to classify one of the studies, which was a Mass Drug Administration thing rather than a test and treat. They classify that with the test and treats because they say, well, there was very high prevalence in this area. There was 93% prevalence, so we're going to classify it with the test and treat. But the issue is there was another study which had the same prevalence level, I forget if it was 93 or 94, but had a smaller estimated treatment effect, and they classified that as a Mass Drug Administration. So those are some issues with it. So together with a number of other co-authors, but principally Kevin Croak, who's in the World Bank Research Department, but also Ted Miguel and Joan Hamori Hicks and Eric Hsu, we've been working on a meta-analysis on weight. So following their approach, and let me start out by sort of following their approach, relatively closely. But we added additional studies. These were ones. 4 of them weren't identified, weren't discovered by Taylor Robinson. 6 by just extracting additional info following the Cochrane Handbook procedures, sometimes contacting the authors, sometimes getting the raw data, using difference in difference estimates to get more precision, using ANCOVA to account for baseline imbalance, and there was at least one case with apparently conflicting reporting, and we contacted the authors. Okay, so what do we get? Well, the first thing I'd like to talk about is, what about the simple fixed effect? Can you reject a null that the point estimate, can you reject a null that the effect is always 0? This, I would argue, corresponds most closely to their, the way they summarize their results. Well, even with their data, without making any adjustments, you reject this at the 9% level. If you use the categorization of studies used in their prior work, you reject at the 1% level. If you use the full sample, you reject at the 1/10 of 1% level. If you restrict the sample to places where WHO actually recommends deworming, you reject at the 1/10 of 1% level. This doesn't depend on some, a bunch of weird updates all being exactly right. We identified 6 updates to their data. Any one of those reduces the p-value to less than 5%. So what does that imply? That implies that there are going to be at least some settings where Mass Drug Administration affects weights. Okay? Now, because we don't think there's the theory and the data both say you can reject the hypothesis of a common effect everywhere. There's different prevalence levels, different intensity, different worms, et cetera. So there's no reason to think that the effect would be the same everywhere. But you can reject the hypothesis that the effect is always 0. Now, that would mean, what would that mean? If you're trying to think about the expected benefit versus cost, if you don't think that there are side effects anywhere, and if you think there are some places where there's 100-to-1 benefit cost ratio, then even this might lead you to decide that deworming makes sense. Even if you thought, okay, there's some places where there's not much effect. But let me go on and actually do the next logical step, which is to do a random effects estimator. So just as background, what these do is they assume there's some heterogeneity in the true effects, and then of course there's measurement error added on to that. So what you observe if you look at a bunch of studies is the combination of measurement error and the true difference, and then you back out what the underlying underlying properties of the underlying distribution. They sort of basically, if you do this in canned data, or I think they use a different package, but they're assuming that the distribution of true effects is normal. Okay? So let me start out by just following that. But there's no particular reason it should be normal, and there are reasons why you might think it's not normal. But if you do exactly what their procedure, if you look at the average weight gain effect with the updated data, you get an effect of 0.134 kilograms, 1% significance. If you this is robust to dropping any single study. It's robust to dropping any 2 estimates with significance levels under 5%. In 96% of the different combinations of 2 you could drop. The largest p-value you can get from dropping any 2 is at 6.7% level. Okay, but if you restrict this to the places where WHO actually recommends deworming, you get somewhat larger estimates. Not significantly different, but you get above 20% prevalence, you get 0.148 kilograms. Above 50% prevalence, you get 0.182 kilograms. I should say, by the way, this might seem dry. I'm going to eventually say a couple of implications of this for people who are not interested in deworming, but are interested in meta-analysis and how we generalize from multiple studies. Okay? Anyway, this implies, given that not everybody is infected in these earlier things, they're including things with very low prevalence. So if you can take the implied effect on uninfected children, if you want to assume that this only affects infected children, which might not be exactly right, but because there may be epidemiological effects, this would give an estimate of 0.3 kilograms as the average effect. And that likely considers a lot of further heterogeneity because the majority of these people with infections have light infections and probably have pretty small effects, but a minority will have higher intensity infections, more worms in their body. By the way, the test and treat studies tend to be conducted in areas with pretty high intensity. So there's higher intensity in those than in these. It also, so that's all just assuming normality. But the data don't actually look normal. In fact, the effects tend to be, large in some studies, small in a lot of studies, but there's no evidence there's a negative. So of the 22 estimates we have one statistically significant negative effect, which is basically what you would assume by chance. And if you thought there was sometimes bias in these studies that could randomly go either way, even more like. So it looks like a somewhat skewed distribution. And in fact, when you test this, a log normal fits better than a normal. Okay. Here's a picture. Oh, yeah. Here's a picture of the studies. The ones in red are ones that were added to what they did. So you can see, there's some studies out here with big effects, a bunch of studies that are, small, and one study up there that's significantly negative. So so then if you, let me just say something here. So if you thought that this was, the assumption of normality here is actually, quite important because, the assumption of log normality is going to another extreme. If you assume that the effects are log normally distributed, then you're assuming that the effects can never be negative, which would suggest, of course, you should be, not of course, but, you're sort of assuming that there's going to be positive effects on average. But the assumption of normal distribution of true effects also doesn't make that much sense unless you think there's significant chance of, because that puts some mass on very negative effects, and nobody's really arguing that there are side effects from this other than short-run discomfort from taking it as you expel the worms. Okay. Let me mention another, I'll try and go through this a bit quickly and then go to the sort of more general results. There's another meta-analysis which followed a lot of the same approach as TMSGG, which just came out. They were much better about identifying the studies. They identified 30 studies, and if you combine them all, they report significant weight gain. but they focus on looking at subgroups. Okay? Other thing I should say about the TMSDG is we looked at the power, and there's extremely low power. Sorry, let me say two things. Sorry, I should have got this better. When we get at these estimated effects, one thing they mean is you can't reject the hypothesis that the effects are the same the underlying effects are the same from the test and treat studies and the mass drug administration studies. So I said the apparent paradox of TMSDG, there's two apparent paradoxes. One is that they argue that there's effect of treating people who have the infection, but not of treating a whole population which contains people who are infected. So that paradox is resolved here because you can't reject the data, the two types of data are consistent with each other. The other paradox is they argue there can't be long run. They argue we shouldn't believe in the long run effects because we know there's no short run effects. But at a minimum, we know that in some settings, there must be short run effects because you can reject the hypothesis of a common zero effect. And in fact, you can go further and say it looks like the average effect is positive once you add these additional studies. Okay. Okay. So here's the other meta-analysis that was done with a lot of the same approaches. But one thing they did, which I think they did out of good intentions in a way, was they said, well, we're going to look within subcategories because, after all, a lot of the medical people who objected said, oh, you can't treat hookworm and roundworm as the same. They're completely different, and this drug is different than that drug. But the key, one of the key takeaways from all this is, if you're doing these types of meta-analysis, you need to report power, and you need to worry a lot about power because the fundamental issue here, as I'll show in a minute, is not so much the point estimates, which differ some, but they tend to do underpowered studies. They fail to reject a zero, and then they say, well, there's no effect. That was the issue. And of course, you exacerbate that problem further if you're going to be focusing in on very small subgroups. So their headline result is for a particular drug, albendazole, given 2 times a year. And there's some other things, but I'll skip. The other big issue is they exclude outliers. Excluding outliers, again, that might sound sensible. But if the underlying distribution is skewed, as the underlying science suggests it would be, given the skewness of intensity and the skewness of prevalence across context, then, and given, not only does the science suggest that, but the data suggests that, then when you exclude the outliers, you're systematically excluding things at the top of the distribution. So they throw, and that's obviously going to bias the estimates downwards. It's also going to give you a false sense of precision because you're eliminating, parts of the distribution at the ends. Okay? So just to give a sense of how important that is, they report their outcomes slightly differently in standardized mean differences rather than kilograms. But their estimated effect for their headline result of albendazole 2 times a year, that would correspond to 0.09 kilograms. So their point estimate was 0.09 kilograms. If you include their 2 outlier studies, the average weight gain is 0.35 kilograms. So, and it then becomes quite significant. Okay? But it's not, let's say we accept keeping out the outliers, but we just change some of their definitions slightly. So imagine you said, well, what if instead of just albendazole, we looked at all drugs? Well, then the p-value goes to 2.5% for the average effect, across settings. If you did albendazole at all frequencies, it goes to, the p-value is 3.4%. They say we want pure comparisons, but some of the studies compare vitamin A plus deworming to just vitamin A by itself. If you include that, then you get a 6% significance. If you do all of these things, you get significance at less than 1%. If you use the a fuller sample, you get effects at less than 1%. Or alternatively, if you keep their approach, but you just say, well, let's look at the places where there's enough worms that WHO recommends deworming. If you look at places with prevalence above 50%, the p-value goes down to 0.2%, or in fact, it turns out to be the same p-value. I hope there's not a typo there. Maybe there were just no studies between 20 and 50. Anyway, I should check that. But I think it's right. The p-value also goes to 0.2%. So, you might say, well, why are we getting such different results than they got? Well, the issue is not that I would argue we're not getting such different results. And this is a point that David Rudman has made. So I should credit him for that. The issue is the approach that they're using of focusing on whether the p-value is less than 5% can be quite misleading. So let me just show you how much they overlap. Basically, they're doing approaches which don't maximize statistical power by not including all the studies, by not using baseline variables to control. Obviously, your weight gain is going to be if you think these studies include kids of different ages, so you're going to have a much bigger variance if you look at only end-line weight than if you look at the difference between baseline and end-line weight, because older kids are going to weigh more. You'll have much more variance, for example. So basically, the difference is we're getting much tighter standard error. We do get a somewhat higher point estimate if you see those green dots. But the basic thing is that we're getting tighter standard errors. And if you approach this not from is the p-value less than 5%, in which case we're going to say there's no effect, but if you instead said, well, what's our best estimate of the effect, then our results would be quite similar. Okay? Now you could then say, well, okay, but should we care about an effect of this size? After all, 0.13 or even 0.3 kilograms might not sound that big. It's pretty big for a young child, but not for an older child. So that's why I think it's important to do this in terms of cost effectiveness. Now, I argued there were educational and economic impacts, but let's say we just restrict things to this weight gain effect in school children. So if we look for another intervention targeting weight gain, where there's a meta-analysis looking at cost effectiveness, Galloway have this estimate of the school feeding. They estimate the school feeding cost. So school feeding is a very widely implemented policy. They estimate a cost of $112 to $250 per kilogram of weight gain. That, if you took that and you took our estimates, that implies deworming is 35 times as cost effective at the weight gain objective, and obviously, there are other objectives, as increasing weight through school feeding. Oh, okay, I'll finish up very quickly. So factoring in other outcomes, both of them increase schooling, et cetera. But, and of course, if you include the labor market effects, then you get these very big effects. Okay, what are some broader lessons? First, so sticking within the frequentist framework, it's important to report the statistical power, which was low in these cases. For interventions that only affect a subset of the population, it makes sense to not report that alone, but to include the estimates from treating individuals known to be infected and combine that all together in a model. Unless you reject the hypothesis that the aggregate effects are different than what would be expected given prevalence and intensity. You should report a test of zero effect. You should get all the power you can. The assumption of normality and of dropping, and therefore of dropping outliers is not innocuous, so it certainly makes sense to report robustness to that. But more fundamentally, I think it makes sense to move to a Bayesian decision problem analysis. We've started to do that, so you can reinterpret all of our results as results with a very diffuse prior over the effects. But another prior would be say, well, let's have the prior based on the test and treat effects. Then we would get a slightly higher estimated weight gain. You can also say, how bad would your priors need to be about deworming for you not to do this? Well, I won't go into details, but you can put imagine your priors were such that you put a 90% weight on zero probability and zero effect, and only a 10% prior of positive effects. You would then get you would still wind up doing this. Okay? One fundamental point is the way that these meta-analyses are often done, uncertainty, because if you say, is the p-value greater than 5% or not, either uncertainty about effects or heterogeneity of effects across different sites will tend you to say, oh, this isn't as good, and we don't want to do it. In fact, if you put this in an economic framework, if you assume diminishing marginal utility of health, which is very standard for economists, then that actually strengthens the case for mass drug administration. If deworming has, given the same estimated average effect, if deworming has very big effects in some contexts and smaller in others, that means that the worm burden is really hurting your health in some places, but in other places it's light, it's not hurting your health. If you don't know which place is which, there's more. It becomes more important to do this if you're. But again, sort of the final comment I'll make is that this, the debate that's happening now of is deworming good or bad is mass drug administration. It's not deworming. Everybody agrees you should treat those who are infected. But does mass drug administration make sense? That's not the right debate to be having. By continuity, in a population, if we know there's an effect in a population where everybody's infected, we know that if there's 97% of people are infected, it's also got to be a good thing. If we think deworming doesn't make sense when for uninfected people, which you couldn't really quarrel with, then if there's 0.5% of people are infected, it's not going to be cost effective. So what makes much more sense is to try to figure out whether these WHO thresholds of 20% and 50% are at the right place. And there, I have no idea whether they're at the right place. To do that, you'd probably need to, try to model these things much more carefully, rather than just trying to sort of plug the data into a formula which you think is into a statistical package which you think is assumption free, but in fact assumes normality and therefore is not assumption free at all. So I guess I'm going to argue for, I guess I'm thought of as an RCT person, and but I think compared to one thing I've learned about working with health people is, we're all like structural people compared to the health people, and I think we would bring in a little bit more theory, makes sense. I don't want to imply that all the health people have this view. Most of the health people have the WHO position, which is to continue this, but they don't know they just have an intuitive sense that something has to be wrong with these studies. I guess what we're trying to do is figure out what happens if you try to do these studies in a more sophisticated way. Thanks.
Okay, I think we are kind of running late. So because the boss is waiting outside, so maybe we'll take one quick burning question. Must be quick.
So Michael, I wonder, this sort of all this effect on weight per se sort of ignores how the medication might affect the returns to caloric intake or how parental response are to return to caloric intake. And I just sort of wonder, it could go either way, right? It could be that it increases the return to caloric intake until parents are spending more money on food and they'll be subtracted out. To what extent is this the right debate to be having without really understanding what is underlying the cost of healthcare? Like, why are we focused on weight as an outcome?
Yeah, I would agree that I would tend to say, well, let's look at these long-run outcomes, which are what we really care about. But partly, why are we focusing on this? That's, we're trying to stick as close, at least to begin with, we're trying to stick as closely to these this Cochrane review as possible, and they focus on weight because that's what the underlying studies report, and that's, in fact, there's vastly more. Everything else that they look at has vastly fewer data points, so that's why we're looking at weight. But their argument is, remember their argument, which is there's no effect on weight, and therefore there can't be these long-run effects. And so if you show that there is an effect on weight, then that at least in some circumstances there's an effect on weight, then that sort of says it's legitimate to look at the long-run effects.
Okay, thanks, Michael, for the enlightening talk. So I'm closing the conference on behalf of Washington University in St. Louis. I have to announce, I really feel very happy repeating the second collaborated conference with Academia Sinica. So the last one was 5 years ago. And may I ask Kamham and Zhiting to stand up so we can give them a big applause. Yeah, I would also like to thank the wonderful chairs, great service from Xianming and Minren, and I would like to thank them too. And Bin Long, who is not here, sorry. And the conference cannot run smoothly without all the young ladies and the young boys, walking around helping us, and let us, give them also a big applause. And the conference is over, and I hope to see many of you 5 years from now. Thank you.